Alright guys, so for this topic we're going to be talking about compound interest. So what is compound interest? Compound interest is pretty much how much additional money you gain based on your initial investment. So here's an example. You have an initial investment of $300 and you earn an annual interest rate of 20%. How much money will you have in a year? How much money will you have in 2 years? So there's two different questions going on here. Let's address them one by one. The first one is very standard, right? I start off with $300 and I'm investing this at a rate of 20%. They said by the end of the year, I will have an additional 20% of my initial investment. So this is 20% of, means multiplication, my original investment. So the total I'll have is 300. The total I'll have at the end of the year is 300 plus 300 times 0.2. So what I'm going to do here is I'm going to factor out this 300, and it's going to look a little bit simpler. It's going to look a little neater. And actually, before we write the 360, I'll write it like this: 300 times 1.2. So at the end of the first year, if I start off with $300 and I have an interest rate of 20% annual, by the end of the year, I'll have $360 in my account, which is awesome. Okay, so how about in 2 years, how much money will I have? Well, the same thing applies. See this form right here? This is what I'm going to be basing this off of. At first, I have $300. After the first year, I'll have 300 times 1.2. But guess what? I'm going to hold this entire amount in the bank for another year. So that means I'm going to just multiply this whole thing again by 1.2. So this is actually equal to 300 times 1.2 squared. So this thing equals 432. So if I have an initial investment of $300 and I hold it in the bank for 1 year, I'll have $360. If I hold it for another year, I'll have $432. All right, so hopefully that made some sense to you. So this is the general formula for something like this. So the amount my pen is freaking out. The amount I've accumulated is equal to the principal amount. Principal means like your original investment times 1 plus the annual interest rate. Annual interest rate. Interest rate. And I'm going to raise this guy by t, which is the number of years. See how for this guy, there's an invisible 1 here because I raised him, because I held it in the bank for 1 year. For this guy, there's a 2 because I held it in for 2 years. So my principal amount was 300. 1 is just 1. And my annual interest rate was 0.2. That's how I have 1 plus 0.2 is just 1.2. And t was the number of years I held it in the account for. And this will give me my accumulated value, which in this case was 432. So this is the general formula that we're looking at when we're talking about annual interest rate accumulation. Now there's something else we could consider, okay? If my computer will scroll up. So I rewrote the equation again. I'm just going to write an A right here. So the accumulated value equals the principal times 1 plus the annual interest raised to the t. So let's say I invest $1 into an account and I get 100% interest. So 100% is equal to just 1.0. So I'm keeping the same format, right? So annual interest is just 1.0. 100% written in decimal is just 1. And I'm holding it for 1 year. So if I invest $1 at 100% interest rate, which is crazy, how much will I have at the end of the year? Well, following this equation, I'll have 1 times 1 plus 1, which is just 2. So if we look at it on a timeline, it looks like this. At time zero, I start with $1. By the end of the year, I'll have $2. Okay. But what if I want to do this? Rather than having all 100% of that interest rate come at the end of the year, see, I gained that 100% right here at t equals 1 at the end of year 1. Instead of gaining all of that interest rate at the end of the year, what if I want to split it up? What if I take half the interest rate, so 50%, and I split it into 2 different pay periods? So meaning this. What if I, instead of taking 100%, I take only 50%, but I take it at 2 different instances? So on a map, it'll look like this. I start with $1. I'll take 50%, which is 1.5, halfway through. So 6 months later, I'll take half of that 100%. Then 6 months after that, so this is 6 months. Then 6 months later, I'll take the rest of the 50%. And that, how would I write that mathematically? Well, it's given by this. My initial investment, which is 1, times the 1.5 that I gained after 6 months, times the 1.5 I gained for the second half of the year, right? Does that make sense? Hopefully it does. I don't know who I'm asking. I'm not really talking to anyone. So I start with $1. Halfway through the year, I gained half of that 50%, half of that 100%. And then at the end of the year, I'll take the second half. So how much money do I have at the end of the year? Well, if I do this correctly, if I multiply this correctly, I have 1.5 times 1.5 times 1. And that actually equals 2.25. So what have we learned so far? Even though the interest rate here is only 50% rather than 100%, if I have 50% but I have more number of compoundings, meaning I get interest rate not just once, but 2 times in a year, I'll accumulate more money in the long run at the end of the year. Interesting. So let's do another one. What if I chose to take only 1/3 of that 100%? Like this. I take 1/3 of the 100%. So that's 33%, 33%, and 33%. I'm only taking 1/3 of that 100%, but 3 different times throughout the year. So every 4 months, right? So how would it look on a map? Well, after the first 4 months, I'll have 1.33. After the next 4 months, I'll have 1.33 squared. And after the last, I'll have that should be a cubed. 1.33 cubed. This is how much money I'm accumulating. So I start with 0. After 4 months, I'll have this much. After 8 months, I'll have this. After 12 months, I'll have this. So how much do I have at the end of the 12 months? I'll actually have 2.37, $2.37. So again, even though my interest rate is smaller here, see, it's even less than 50%. It's 30%. But because I have more compoundings, because instead of happening only once in the year or twice in the year, this time it's happening 3 times in the year, my ending balance will be greater. And I can do it again, right? I can say, well, what if I only take a fourth of it? So this is 25% of 100, 25% of 1, 25% of 1. And I have 4 different time slots where I get these compoundings. Then it's going to look like this. After 3 months, I'll earn this much. After 6 months, I'll earn this much. After 9 months, I'll earn this much. And after the full year, 12 months, I'll earn this much, which is equal to 2.44. So I'll earn $2.44. So the pattern is the same. The more compoundings I have per year, the more money I'll get. So to generalize, I can rewrite these equations, everything that we just gone over, like this. So this is 100% once at the end of the year, 50% 2 times throughout the year, 33% 3 times a year, 25% 4 times a year. And if we want to generalize how this works, we use this formula right here. Let me zoom out just a hair. Right here. So the accumulated value here is A. P is the principal. R is the annual interest rate. N is the number of compoundings per year, right? Just like for this guy, there were 2 compoundings per year. That's why we had 50% of our total. And what else do we have? T. T is for how many years this is happening. So there's an invisible times 1 here because in my example, we were compounding only for 1 year. So hopefully that makes sense. The lesson here is that the more times you compound throughout the year, the more money you'll get in the long run. So obviously, as an investor, I would love to make as much money as possible. So I don't even want like an integer value for a number of compoundings. What I want actually is an infinite number of compoundings throughout the year. It's a weird statement, but that's how it goes. If I were to get an infinite number of compoundings per year, or as they call it, continuous compounding, it'll lead you to this weird, mysterious, yet simple formula of, gosh, I wish my computer worked. There it is. A equals P times E to the RT. See this guy right here? This weird number pops up. So if I want an infinite number of compoundings per year, which is also known as continuous compounding, I'm going to use this formula right here, where A is the accumulated amount, P is the principal, R is the rate of interest, T is the number of years, and E, see this E right here? This weird thing that popped up? That's Euler's number. Don't say Euler, it's Euler. Almost spelled like this. So it's Euler's number, and it's an irrational number. You see it on your calculator, you see it, well, you probably don't look at math memes like I do, but it's in a lot of math memes. And it's about 2.71, okay? It's a really weird number, and because we don't go over any limits in this class, I can't really show you guys where this number came from, but just trust me, as we pick or go towards an infinite number of compoundings per year, this is the formula that we'll use. and we'll start using this guy E. All right, so let's do a couple of examples. It's easier than it seems. As always, it's always easier than it seems, which is a good thing. All right, so the first example. We have an initial investment of $8,000, and the bank is giving you continuous compounding at 6.85% per year for 6 years. What is the accumulated value? Or what is the ending balance? So the key word here is continuous. That is the key word. Anytime you see the word continuous, this formula should pop up right into your brain. There's two instances in this class that you'll use this formula. One is for population growth, which we'll talk about once we talk about logarithms. And the other one is continuously compounding investments. So the key word here was continuously compounding or continuous. So we're going to use this guy. Okay, so they want to know what will be our accumulated value at the end of 6 years. So it's very simple. All we got to do is fill in these variables, okay? So what does P represent? P represents our principal amount, which also means our starting value. So what was our starting investment here? Well, it was $8,000. And I'm going to multiply this guy by E. Remember, E is just about 2.71. It's like a number. Obviously, it keeps going forever. It's an irrational number. But, oh, I just heard a weird noise in my room. Anyway. So, I lost my train of thought. Okay, so my principal value was $8,000. Then I have E, Euler's constant. And I'm going to raise E by the interest rate, which is 6.85. How do I write 6.85%? 6.85% into decimal form? Well, all I do is I take this this decimal and I move it to the left by 2 spaces. So it's 0.0685. And now I fill in for T. What is T? T is the number of years this whole thing is going on for. And the question tells us that it's going on for 6 years. So right here. So because E is irrational and you're dealing with exponents, you probably won't be able to compute this in your head. So grab a calculator, figure it out, and I may have put the wrong thing in my calculator. Let's see. I have E. Jesus Christ, sorry. I should have done this off screen. 0.0685 times 6 times. Okay, maybe you guys can double check me. This is what I got. 0.66. 12,066 and 60 cents. All right. So that was very straightforward. The only hard part of this problem was identifying which of these two formulas we should be using. Is it the n compounding one or the infinite or the continuous compounding one? Because the word continuously was in there, we decided to use the second one, which was the right choice. All right, let's do our last example for this lesson. An account has the option of having 7% interest rate compounded monthly or 7% compounded continuously. So a bank is offering you one of these two options. The awesome part about this section is that this is like one of the few times in this class that we're addressing real life problems, right? So this kind of stuff happens. You go to a bank, you start a savings account, you got to figure out which interest rate is better for you. Is it Chase? Is it, I don't know, well, Wells Fargo? Is it, who knows? I heard a lot of online banking has really good interest rates. So check that out too if you want. Okay, so let's go ahead and start this. So the first one we'll deal with is this guy, 7% compounded monthly. Now, he's compounded monthly. He's not being compounded continuously here, but he's compounded for some number of times per year. So let's go ahead and let's use this form. Okay, so let's use this. A equals P times 1 plus R over N times N. So let's just pretend that this is good for 1 year, because the question wasn't really specific. So let's just go ahead and fill in the blanks. What is our initial investment? Well, because they didn't tell us or give us an initial investment, we'll just say it's 1. Our principal here will be 1. Just make sure whatever number it doesn't have to be 1. It could be any number. As long as you give both this guy and this guy the same principal amount. As long as they're the same, it doesn't matter. All right, so I have 1 times 1 plus. Now what is my interest rate? 7%. So I have 7%. I'm going to rewrite this in decimal by moving my decimal place over 2 spots. So I have 0.07 divided by 12. N here will be 12. Because it's being compounded for, it's being compounded monthly. How many months are in a year? 12. And we're going for 1 year. Okay, so this is the value for if we were to choose the 7% compounded monthly. So this would be equivalent to, obviously, you would have to use a calculator for this part. Boom. Okay, so the next one is compounded continuously, right? We found the key word here, which is continuously. So again, we're going to use the above formula, which is A equals PERT P times E to the RT. Again, fill in what we know. Make sure these guys, because they didn't give us an initial amount, whatever it is, just make sure that these guys are the same. Times 1 plus, times E to the 0.07 for 1 year. And this value is approximately 1.0725. So everything is the same except for this guy right here. This 3 versus this 5. So which one should you pick? Well, you're going to get, honestly, right, for if you're only storing it for a year, it really doesn't matter. But you get just a little bit more with this guy. Okay, 5 is slightly greater than 3. So if you really were nitpicky, let's go ahead and pick this guy because you get more money in the long run. All right, guys, hopefully this made sense. I will see you guys in the next lecture.